In this video, I will show you the Quartic process optimization application and how it can be used to improve your processes, targeting objectives such as improving yield, reducing step loss or cycle time, or minimizing energy consumption. Quartic's first-of-its-kind Bayesian optimizer removes the typical requirement of a large historical dataset to train a machine learning model, and also removes the need for a complete mechanistic model, which can be difficult or in some cases impossible to build. Instead, we rely on simple inputs: the objective you want to optimize, like improving yield, a process recipe or previous batch runs to serve as a starting point for the optimizer, and variable constraints. For example, how high or low can the optimizer adjust a temperature or a pH, which is often also part of a recipe. From this simple information, the Quartic optimizer can run and provide optimal set point recommendations to an operator, or even directly control equipment for closed-loop AI control. The idea is using minimal upfront data, we can build a machine learning model using Bayesian methods and deploy it to optimize your processes, either to provide recommendations as human-in-the-loop AI, perhaps sending those set points to an HMI screen for an operator to implement, or in an online learning mode for fully autonomous closed-loop control. So with that overview, I'll open up the optimizer application so we can see it in action. So I'll start off by giving my project a name, and next I will set the project conditions. And in this case, I will be optimizing the yield on the penicillin fermentation process. First, I will choose the objective I want to optimize. In this case, I want to maximize my yield. And I don't have any historical batch runs in this case, so instead I'm going to use my recipe as a starting point. Within my recipe, here are the different process parameters I want to control. I have a starting value for them, and an upper and lower search space for each time interval of my batch run. This is shown visually over on the right-hand side. The dark orange line is my starting point for the optimizer, and the lighter orange band is the allowable search space, and I can see this for each one of my process parameters that I'm going to control. So that's it. Those are the only inputs that this optimizer needs to run. I don't need a huge historical dataset, and I don't need a mechanistic model. Now that this is set up, I can set a number of optimization runs because I'm not running this in real time on an actual process. What's happening here is the optimizer will make set point recommendations, feed that into a penicillin simulator I have running in the background, and that simulator, which is a digital twin, will provide the real-time sensor values and quality values that will then get fed back into the optimizer for the next run. And then a new set of set point recommendations will be made. By doing this, we'll be able to quickly iterate over 10 batch runs rather than need to wait days or weeks to see the batch runs complete. We can see each batch run going and our overall yield as the optimizer works. One thing you'll notice is for these first couple of runs, the yield actually drops a little bit. This is because the optimizer is testing that search space to learn how to optimize this process. If you need to limit this initial drop, if you have historical batch runs, that data can be used to pre-train the optimizer. Or, if you don't have previous data, you can more tightly constrain your process parameters on the recipe page for the first few runs to ensure the yield won't drop too low. And then after a few batches, once the model has learned, then you can widen the search space for full optimization. Or finally, if you do have a mechanistic model available, or we can help you build that digital twin, that can also help constrain the search space as the optimizer is running. So to continue, over on the left-hand side here, these are the actual set point recommendations coming out of the optimizer, and I can see this for my different process parameters. Then down at the bottom, these are trends of the actual sensor values coming out of your process, or in this case out of the simulator. So the variables that we're controlling, but also some of the other variables that we're not directly controlling, like pH or penicillin concentration, which are the results of the process. So as this iterates, we're able to see how each one of our batch runs comes in. We can always see our best yield run so far versus our current run. And as the optimizer narrows in on the optimal settings, the yield begins trending upwards and will then level off and produce consistently higher yields than before. And that's the goal: better, more consistent results. And because our optimizer is designed to run and learn in real time, it can take into account the ever-changing conditions of your process or of raw input materials and incorporate that variation into new setpoint recommendations. Now, this is the view of these recommendations within the optimization application itself, but because it's also tied back into the Quartic platform, we can also expose these results and recommendations to other tools. For example, back to an HMI screen for an operator, or to a dashboard like this one in Power BI, where we can show our optimized yield profile alongside optimized setpoint recommendations shown here in green for the controlled parameters. So hopefully this gives you a pretty good understanding of the capabilities of the Quartic process optimization application and how it can be used to optimize any key performance indicator of your choosing, yield, which we showed in this case, or cycle time, energy usage. And this application is available off the shelf and is configurable to your specific process and needs. This will accelerate your optimization project timeline, especially when it involves new products, equipment, or plants where large historical data sets are typically not available. So with that, I'd like to thank you for joining me today, and if you have any questions or like to learn more, please reach out to us here at Quartic.ai.